Okay, good. Yeah. Good evening, everyone. Thanks for coming. Thanks for lovely hosts and stuff. I'll get through a short talk. I'm Daniel. I'm one of the engineering managers at Schibsted at the infrastructure team. I'll just go through a few things for you this evening. So just I'll go very brief intro about Schibsted and why actually we do the things we do. And then I'll give you an example, hopefully not too war story, of a global scale service we recently been working on. Then four useful, what we call useful patterns, as in experiences we got when developing that stuff. And then the typical page of lessons learned. So scars we got on our bodies, not literal ones. So basically, just briefly about Schibsted, it's basically a media company that has marketplaces all around the world, and also media houses, as in newspapers, etc. It's quite a big one. We are in 31 countries, and we have like 7,000 employees, around 2,000 engineers, more or less. I think a bit less. And throughout those countries, we actually have more than 200 million users. So, yeah, and that comes with some interesting challenges, actually. And this is a map of the countries we're in, a bit here and there. I don't get to get meetings here. I would love to, but not yet. I'll come up with an excuse. Definitely, it's quite nice to kind of work with people from all over the place.
Sorry, which countries? Is
Uh,
it the light blue ones or
Actually, yeah, good point. It's actually the dark blue are the ones in, so it's like the risk game. Yeah, so good point. Actually, that's a good one. Yeah, thanks for spotting this. Still, I'm not getting any meetings in Australia anyway, but I'm working on it.
not in UK yet?
Yeah, not yet, but we do have an office in London. Actually, it's a development place. So, and this is one of their websites, actually the one in Paris and in actually France, in Le Bon Coin. And it's a marketplace of change goods. And it's actually on the top 5 sites in France, which is not that bad. And yeah, those guys, they're awesome, and they get us a lot of projects. And basically the idea is to go through one of the services we've been working on recently, the last year, more or less. And it's what we call the image service, which is a global scale media storage and delivery service. It's basically a system to deliver images and other kind of documents to end users. It doesn't sound very sexy, but actually when you get to it, it's a nice project to have. And also we plan to expand it to video and other types of media. So yeah, it's good. And it's designed to work on a global scale on those dark blue countries. So definitely, there's quite a few challenges there, and I hopefully will explain some of those to you. So some of the features, it has quite a few features, but some of the basic ones is for instance, image transformation on the fly. So when you have mobile devices, etc., you want to transform images on the fly, and it's actually multi-tenant, and it works as a software as a service within the company, because we have all those sites. We actually have to set it up so it's like an SAS for all our kind of internal customers, which comes with their own challenges as well. But it's quite interesting to work like that. And because we want it to be very fast, we use GPU acceleration, which kind of helps with for instance, image transformations and stuff. And yeah, scalability, high performance, blah, 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 etc. So you can translate that as sleep well at night, basically. And yeah, there's a few more features about direct uploads, etc. And yeah, we're quite excited. And it actually makes sense for our size to develop it internally. There's some, it's quite a common service. And people, there are actually some in the market, a few people that actually offer this as SAS. But for our size, it really makes sense to have it internally, have all the images there, be able to process them for image recognition, etc. So it makes a lot of sense for us to develop it internally, given our size, basically. And this is the typical architecture diagram. I will not go through it that much, but it's microservices. But it's definitely like a bunch of services at the back end. This is actually deployment shows a deployment in Amazon, which we use for some of our stuff. And there's basically 2 lanes of services, one for internal users. And when I say internal users, it's actually our sites that add stuff to the system through a bunch of services. We use Cassandra to store the business rules. So actually, the sites can define their own rules to add and deal with stuff. And then, yeah, a bunch of services here and there, store configuration in DynamoDB, and S3 for the raw data, which is, it works like a charm. And then we have basically the other lane, which is the delivery lane, which is where actual end users ask for content. And yeah, we didn't want to add a lot of microservices, but still works with a few services and then a few layers. So front end, middle layer, gateway, and then kind of some backend microservices are there. We have a redesign. There's actually a few weak spots here. We'll not talk about them, but there's a few. And we're actually adding a couple of more separation layers to make it a bit more streamlined and provide more abstraction. And actually, it runs on Amazon, but it could run somewhere else, given we change a bit, some bits here and there. But it's designed to be abstracted from the actual storages, etc., where it's deployed. In theory, I think we should be quite okay with that. Just to mention a couple of key components that are not in the diagram, but we, in this project and many others, we leverage some components by Netflix, the open source Netflix components that Netflix has kindly given to the open source community. In this case, I showcased 2 of them. We use quite a few and won't go into detail, but for instance, Hystrix is basically circuit breaker component to do some resiliency stuff. I'll kind of explain a bit more later. And then Ribbon for client-side load balancing. So to get rid of server-side load balancers, we use Ribbon, and it works like a charm. So definitely quite happy about those. So I encourage you, if the ones, just out of curiosity, anyone that has used this before? No? A few there? I encourage you to check them out, because we're quite happy, and this runs in production really well. So hopefully you guys can check it out at some point, and hopefully it will give you some ideas. Then some fun facts about the system. And this is actually less than, so basically it's been deployed to maybe 10% of our actual traffic, more or less, give or take, a few percentage points. And we upload to the system at least 1 million images per day. It's not that bad. And before caching, because we put a CDN, a few CDNs in front, we serve around 25 million transformed images. And they're actually PDF documents, and attachments and stuff, which are a bit in the minority. Some latency figures, actually serving the images is 70 milliseconds. And the vast majority of that is actually fetching it from S3, because they're actually hard drives or whatever. There's no physical hardware, that it's not magic. Some code has to run and get the image to you and then deliver it. So most of the latency is actually there on S3. Still works like a charm, and that's quite low. And the transformation, because it's GPU, it's quite a few, really quite fast. So not a significant chunk of that. The upload is a bit slower, but not by much. And actually, most of the latency is also on actually getting it into S3. So there you go. Which, by the way, works pretty well. And the failure rate, it's 0.0000875%. But actually, this is before the latest patches we've run in the recent months. But I wanted to highlight that it's, for some places, unfortunately, maybe some of us have worked before, this is an acceptable rate. But we haven't been really happy with that. So we worked, and had some ideas about bringing basically this to 0. Whoa. So password, short one. Yeah. So we have been working to basically bring the failure rate to 0. And then a few errors pop up when there's an issue, but they actually want to be 0 out of whatever million requests we get. So this is one of our objectives there. And to accomplish that, amazingly on time so far. To accomplish that, we actually had hit a few roadblocks, to actually get the errors to 0. Nothing. You have millions of requests, no errors. And out of that, we came some war stories or lessons or whatever, patterns. I didn't want to put architecture patterns because I really don't like the term. So no architecture pattern. Useful lessons or whatever you want to call it. One of them, unless you guys might be familiar with, but it's when you do microservice, especially microservice architecture, you really need circuit breakers. It's basically, there's many tools out there that do it, but in this case, the two Netflix OSS ones we used, and Hystrix and Ribbon, which I mentioned before. Basically, I put a tiny little diagram here, which is you got one of the services inside the system gets incoming traffic, and then the instances distribute the load on the client without a load balancer in between to all the instances you have at the back. Well, back end, if you want to call it. And then basically Hystrix is there to do the circuit breaking, which happens sometimes. Imagine you get one of the instances to start to have a lot of high latency, which you might find for many reasons, bugs, software bugs by a developer, for instance. And then basically this is detected by the Hystrix framework, and it says, okay, this guy is not cool anymore. And before any health checks, it's a bit important, I think, to highlight that before any health checks kick in, you might have in the system, the client already decides this instance is not good. So basically it's not going to use it anymore and distributes the load to the rest of the instances out there. And that basically means that if you apply it well, no request is lost. So that one is retried. And basically you would have an issue if it's a system that it changes some state, then you might have an issue with that specific request, that it gets lost somewhere. If it's stateless, you'll be okay. So this guy will actually retry that failed or slow query into this other instance, which is actually okay. And then probably, that some other systems, such as health checks, etc., will mark this as unhealthy, and then take it out of the scaling anyway, which wasn't there anymore. So these guys were not calling it. And then you add another one because you have whatever. You restart it, you have an auto-scaling group, whatever system you have. And this has saved us, actually has gone really, really well. I was quite shocked to see how well this works. So, and we have got all sorts of problems, and there were virtually no failed requests from the point of view of the user. So it's super cool. Even though a few here and there, they actually slip through the cracks sometimes, but it really brings the levels of errors to users to near 0. And this is quite important, obviously. Which brings me to the next, the second out of 4 patterns, which is basically what we call the 0 error policy, which is striving to say, okay, I've got all these goodies to shield users from actual failures. And you can't retry those latency problems, etc. And actually, there are a few instances, depending on your architecture and the hardware you use, etc., that actually you cannot consider failures as failures. You just retry, and there was a blip, a glitch, whatever, and that's fine. Don't even if it's just from time to time, just ignore it. You would call it a problem when it happens more than you expect. Otherwise, it's fine. On the other hand, we strove to say, even if I have 7 requests out of 5 million that actually didn't go well and went to the user as a problem, and maybe the user is just reload the page, and that's fine. Oh, I see image down. It's still nothing we like. So we say, let's take that as an incident. Someone gets page, 5 requests failed out of 2 million or whatever, 3 million. Let's have that as an incident. Let's go through through the motions to handle that, and then try to find a fix for it. Just what was actually wrong with this. And we had a few instances, obscure I don't know, obscure memory leaks and stuff due in heavy loads. And it's like, it wasn't okay to have 5 failed requests. Let's get it to 0. And then wait until the next 12 or so, or 5 or whatever requests are failed, and then fix that problem. And we like that kind of approach so much that we're trying to apply it to other services. It has a cool name as well. Another one is basically I think it's quite common to say, okay, let's just stress test these kind of systems. This is kind of an obvious approach, but once you get down to it, simulating traffic across the globe, it's quite hard. It takes a lot of effort to say, I want to simulate real traffic that it comes from many countries, blah blah blah, etc. So you say, okay, actually in our case, in this project, we have sites that are going to migrate from our legacy system into this new one. So what we did is that instead of doing a simulation, let's ask these people to send us all our requests asynchronously. So they kind of do their business day to day, it's fine, but also send us all our traffic in parallel. So, and then you call it fire and forget, just send it to us. And we kind of ask, because it's a lot of millions of requests, start small, do 10%, 20%, and then progressively increase the traffic until we find 5 requests that failed, and then we fix the problem. Okay, and this really helped. It was easy to set up. The guys that tried it internally in production, it really didn't affect the systems. It was super good. Instead of spending hundreds of hours trying to set up a cluster worldwide of simulated traffic, do this. Well, at least it helped us a lot. And actually, we found some bugs, obscure stuff that was related to heavy traffic found during this process. So quite happy about that approach. And once you're 100%, you say, actually, I'm ready for the switching, load-wise and functionally wise. And the last word story, still on time, hopefully, is I had to put a meme on the screen because there's no presentation without a meme. But we kind of discussed resiliency. We discussed as well load. But actually, does it work? So what we did in this case is you have usually you do, for instance, integration tests after builds. This we do fine. It kind of prevents you from doing some regression problems, etc. And you also, and we still do it as well, you do kind of periodic end-to-end testing. From time to time, every minute or so, you launch some end-to-end tests. That's fine. It tells you that system is pretty good. But we felt, and actually some of our engineers in Mexico were like, we want to go beyond that. So we trust you that it works, but we actually set up the watch, which is the shield that guards the realms of DevOps. I had to look it up, but it's cool, and they put a cool name to it. So basically, it's a system in this case that fired up a couple of million requests to us of actual user data using log parsing, and say, I want to send you 2 or 3 million images, and then request them, and check every single one of them. Check for integrity, for the HTTP headers, check for it is actually an image that you're sending me. You might be sending a header, but not an actual image. It might be corrupt. And we actually found some corrupt ones, etc. So, and these have really helped us to uncover some of the most obscure bugs. So, and we liked it. It was a really cool idea, and it really helped. Because when you do like one integrity, for instance, one check every minute, you check 1 request, or 10, or whatever. The other thing is to fire up 2 million requests, not at the same time, thankfully. So that was like really concept, and we want to extend it as well to other projects. And finally, still on 1 minute left or something. So lessons, the circuit breaker stuff. There are some tools out there. We use the Netflix ones. They're super cool. They hide failures from users, but still, it's not a way to keep the system healthy. It's a way to keep the business healthy. And then you actually have to treat whatever happens at the backend as a problem. what we call the zero error policy. It's a mental framework, if you like, to improve the quality of the system. No errors at all, zero. Then they come up, it's inevitable. But treat that as an incident. If it is three out of 1 million, still a problem. And the rest, the other one was about the stress test. For instance, in this case, we use Locust for plain vanilla stress testing. But we kind of gave up to try to simulate like worldwide traffic. We just used the fire and forget idea from the clients, if you like. And it was a very, very effective way to simulate traffic without a lot of effort. They set it up in an afternoon for us, and then they increased the traffic along progressively. It was super cool. And then the watch, apart from the cool name, it was very, very useful to uncover bugs, but there was a thing which is it actually keeps your system warm. It keeps the cache warm, it keeps the balancing up, and then we turned it off. Okay, it works. We validated the 2 million requests, turn it off, and then strange things happen to your balancing. So we actually create an incident to us by turning this thing off. So if you guys try a similar idea, just be careful when you turn it off that it actually will get your system cold, so to speak. That was a fun evening. And yeah, speaking of fun, it's actually in this project we had a lot. We really enjoyed developing it because it's large scale. It's designed for worldwide traffic, but still, you can tackle it. It's fun, especially when these things happen. And yeah, that's it on time. So thanks for your time. We also hire, so we have like office in London, in Barcelona, Stockholm, Oslo for like development hubs. I think we have to get 100 people or something. So, but if you guys are interested in anything, just check out the website or drop me an email or grab me after at the refreshments, and we're happy to discuss this or anything like that. I don't think we have time for questions. Maybe at the end.
Do you want to take some questions while Colin sets up?
Yeah, sure. Anyone? Yeah, here?
So you mentioned that you do integration testing and stress testing
Yeah.
and threat testing. How many times are you able to deploy a day? Is that being quite time-consuming process?
It's using it's fully automated, so we don't do like lots of deployments a day, but we actually do deploy the microservices individually. So you don't really do large deployments. So whenever an engineer needs to do a change, they do it. But we don't really do like a cycle that does it continuously the whole thing because it's quite a big cluster. So
With stress testing, did you decouple that from a release, or how did that specifically?
we do it independently. And also what we do like automatically is definitely the smoke test every minute to make sure that the actually functionality is doing okay, because we had a few kind of manual mistakes when deploying the cluster that kind of set things wrong. But we haven't coupled it because we don't do functionally wise. It's not like a end user product where you do rapid iteration. It really is a bit more stable function wise, so we don't need to do that really.
That's it. So
Yeah.
thank you.
Yeah, thanks a lot.